Imagine yourself a 10-year-old kid in the 18th century in a math class in Germany. And you don't have pen and paper, you've got a chalk slate. You write all your notes on the chalk slate, you memorize it that night, you erase and come back and take notes the next day. Your teacher gets pissed off at you and says, here, do this one. And so you say, okay, well that's really 1 plus 2 plus 3 plus da-da-da-da, all the way up to 99 plus 100. Now, still imagine you're this 10-year-old kid. Can you tell me the answer to this? Even if I gave you a minute or two, could you tell me the answer? Probably not. Well, a little kid by the name of Carl Friedrich Gauss, the same Gauss as in Gaussian elimination, cheekily went up to his teacher's desk, threw his chalk slate on the desk with just one number, 5,050. And of course, it was the right number. So wow, how did he do that? Well, I could probably take a few guesses as to how he did it. But let me show you how we're going to have to do it. And that is, we're going to work with either of these two formulas. And they're to help you calculate the sum of an arithmetic sequence, sum of the first n terms in an arithmetic sequence. You might want to copy these numbers or these formulas down. Now, there's really two different problems here, or two different formulas. This is just rewriting this one. I like this form better. That should be a 2 there in the denominator, not a 4. I like this form better because it kind of shows you a little bit what's going on. If you want the sum of the first n terms of a sequence, you're going to average the first and last term and multiply by n. That's a nice way to think of it. If you don't have that last term, if you just know I want to sum of the first n terms in your arithmetic sequence, then you can say, oh, well, it's this. So either way, you're fine. But the problem is you need to know n. And that's where the sticky part comes in if you're given a problem like we have in example A. You don't have n. So you need to figure out n. Kennedy, maybe you can remind me, what's the general form of a term in an arithmetic sequence? How's that look? I'll help you out. It's going to be a sub n is a sub 1 plus n minus 1 times d. Let's see if we can write that for this sequence. So let's see. That'd be a sub 1. Well, a sub 1 is what in this particular sequence? That's our first term. That's 87. Plus n minus 1 times d. What's d for us here?
-4.
-4. Perfect.
What if a sign flips and would do like 87 minus 4 and then n minus 1? Does that make a difference?
No, well, addition is commutative, so I can add those in either order. So if WebAssign writes it a little different than me, then they're wrong. All right, I'm kidding. They're not wrong. It's just not to my taste. But with this formula, I can now figure out what n is to give me 11 here. Now, I know you can do that by subtracting 4 often enough. But on the test, I'm going to make sure that this number is big enough, or this difference is big enough, that you're not going to be able to keep on subtracting 4 or doing something like that. You're going to actually have to use a formula. So let's apply that. We're going to have 11 equals 87 plus n minus 1 times -4. So how about if I start by subtracting 87 from both sides? That's going to give me -76 equals n minus 1 times -4. Now I'm sure that there's those of you out there who would be tempted to multiply by the -4. I'm going to just divide both sides by -4. I find that really convenient. So if I divide both sides by -4, then on the left-hand side I get 19. On the right-hand side, those cancel, and I'm left with n minus 1. Add 1 to both sides, and I get 20 equals n. Yay! So really, this is the 20th term in the sequence. So now I've got what I need. And what I needed was n. So I can plug it into this formula. The sum of the first 20 terms is going to be 20 over 2 times, where is the first term? 87 plus the last term. So that should be 980 when we do out the arithmetic. Cool. The important thing to see here is that I had to calculate what term n was. I had to figure, or 11 was. I had to figure out that that was the 20th term in this sequence. So how are we looking with that first example? Thumbs up? All right, thank you. All right. Let's try another one. Example B. And all that's given in example B is that the 14th term is 1/2 and the 9th term is 1/12. So that doesn't feel like much to go on, but it's enough, as it turns out. Let's start out by reminding ourselves that this is the general form of an arithmetic sequence, and they do tell you it's an arithmetic sequence. That means if I plugged in the 14th term, 14 minus 1 is 13, I get a sub 14 is a sub 1 plus 13 times d, and that's 1/2. And I can do the same thing with a sub 9. Notice that it gives me 8 times d, my common difference, and that's 1/12 there. It's these two that we have to solve as a system of equations. Now, just as a reminder, you have a lot of ways you can solve a system of equations. I can name 6 that we've done in this course without really breaking a sweat. Substitution, addition, graphing, Cramer's rule, inverse matrix, and Gaussian elimination. Wow, there's a lot of ways you can solve this. We don't need to take out a sledgehammer to do this one, so that would eliminate Cramer's rule and Gaussian elimination. Let's just multiply the top equation here by -1. So -1 times that, and I'll add it to the bottom equation. That allows me to solve for d, because the a sub 1's cancel each other out here. I end up with -1/2 plus 12, or how about, excuse me, not 12, 1/12. If you get a common denominator, that would be 6 over 12. So I get -5 over 12. And when you solve, divide both sides by -5, you'll end up with d equals 1/12. So yay. Once you have d, take that value for d, and I'm going to plug it into this bottom equation, 1/12. That gives me 8/12. If you're tempted to write it as 2/3, that's nice of you, but if you keep it as 8/12, then you have common denominators. So when you move this to the other side, you can finish solving because you've got common denominators, and that's the other value that you needed here. We wanted d, we wanted a, or a sub 1. So overall, the general form of the terms in this sequence is -7/12 plus n minus 1 times 1/12. That's your final answer. Beautiful. If there's 2 unknowns, you're going to need 2 equations to solve. So one of the big takeaways from that one. The fractions were a little bit on the ugly side. I'm generally a little bit nicer than that, but hey, things do change. So be prepared. By the way, these are problems that come directly out of your book. So let's see, S2. If you're graphing these things, if you're asked to graph a sequence, make sure you start with a sub 1, and basically you're graphing the value of the term, the number of the term, against its value. So 1 and 2, 1/2 and 2, excuse me, yeah, 2 and 1/2, 3 and 2, etc. So, and last but not least, let's do this one. It says find the number of terms of the arithmetic sequence with the description that must be added to get to the value of 3,360. So what they're telling you here is that the first term is a 5 and the common difference is a 2. So let me take a look at what they've got here and put it in context for you. This is all you're given. That a sub 1 is 5 and d is 2. That's given. You want to figure out s sub something equals 3,600. Well, of the two formulas that I mentioned earlier, I'm going to choose this one because I don't need to know what a sub n is. I don't have a sub n, so I shouldn't probably mess with that. Let's fill in a sub 1 is 5 and d is 2. And I guess the other thing I can fill in is that this is 3,360. Okay. That makes this 10 plus 2n minus 2. And I can clean this up inside a little bit before I move on. Probably not a bad idea. 360 equals n over 2 times 2n plus 8. If I distribute this, I'm going to be dividing each term by 2 and multiplying each term by n. I'll get a nice quadratic equation. N squared plus 4n equals 3,360. So if I move this to the right-hand side, what are my options to solve this? What would you do to solve this? I mean, if push comes to shove, you're like, all right, this is the last question I got to do to get the 100% on this test. What could you do to solve it?
Quadratic formula?
Quadratic formula, that's your go-to. You could also factor it, and that factors as n minus 56 times n plus 60. So
explain how you got a n squared plus 4n. I'm confused on that.
Sure. Let me put in a little bit more detail for that. Let me write this as n times 1/2 times 2n plus 8. All right, so I'm just splitting up the n and the 1/2. N times 1/2 is the same thing as n over 2. You okay with that?
Yeah.
All right. Let me start by distributing first the 1/2 term. So I want to take half of each of these, and that's going to give me n times, well, half of 2n is n, half of 8 is 4,
Oh, okay.
and then distribute it from there. So,
That makes sense.
cool. So I get two solutions, n equals 56 or n equals negative 60. Now if I'm summing up a number of terms, can I sum up negative 60 terms? I don't think so. So the only answer there that works is n equals 56. So yay. S sub 56 equals 3,360. So if you summed up the first 60 or 56 terms of this sequence, that's what your total would be. And that's what they're looking for. Okay, nice. Any follow-up on that one? All right, good luck.